Right, let's look at this calculation from a numerical perspective, because what we want to look at now is the prospective reserve, the retrospective reserve, asset share, and things like that. Okay, so I'm going to do this calculation with actual numbers. So to that end, I have a spreadsheet here, and we need that spreadsheet to go from 35. So this is basically similar to what you will have in the red tables. So we can go from 35 up to 55. And we can pick off the appropriate numbers. So I didn't mention, let's do it on male rather than female in this case, but obviously male and female mortality is different, so you have separate tables for each of those issues. That's a fairly, it gets more complicated when the law requires you to have the same premiums for men and women because of equality legislation, but in terms of actuarial terms, the pure premium is still the calculation, the pure calculation, but that's an aside for the time being. Okay, so what was our premium? Okay, well this was our premium calculation, and then before that we had the annuity calculation, and then we also had the assurance calculation. So let's do those step by step. So let's do the annuity calculation first. So we're going to have, we're going to be doing it at 4% interest, so we're going to have A35, so that's an assurance, A35 minus L55 over L35 times 1 over 1.04 to the power of 20 times that. Okay, that is our annually payable annuity for 20 years. Okay, so it's a 4% and there's some mortality, so obviously it's going to be less than 20, but I think we also so that's annually, so let's put in, let's adjust that for monthly. So I'm going to put minus 11 over 24 in there, and this has to go in brackets because it's the whole of life annuity that we take the 11 over 24 off. Okay, so now worth slightly less. Okay, you can see the two different numbers there, because if you're paying over the whole year, you've got the discounting because they're somewhat in the future, and also you might have died before some of those payments come into place, so you'd expect that to reduce the value. Okay, so the next one we're going to look at is the assurance. So the assurance here again, same principle, A35 minus L55 over L35 times 1 over 1.04 to the power of 20 times A55. Okay, 0.028, which is an approximation to your probability of dying between the age of 35 and 55, adjusted for interest rates. So if interest rates are 0, that will actually be the probability you die between the age of 35 and 55. But again, this has to be payable immediate on death, not at the end of the year of death. So that is the end of the year of death calculation at the moment. Okay, so we want to adjust that by multiplying the whole thing by 1 plus I to the power of a half times 1.04 to the power of 0.5, which is going to be very similar to 1.2, so it's going to add about 2% to it. Okay, and there you go. So that is our basic, that's our assurance calculation. That is our annuity calculation. So our pure premium, okay, equals 200,000 times the assurance divided by the annuity, and that is the annual premium, and then monthly, don't forget, equals that divided by 12. Okay, so a monthly premium of £34.77 to receive £200,000 on death over the next 20 years. Now, what happens when we move forward in time? So this policy is basically going to pay out £200,000 if there's a death, and it's going to receive £34.77 every month if there's not a death. Okay, so let's project that forward and see what happens. So month 0, so that is the calculation we have done. Okay, but I'm going to adjust that. I'm going to take back out the monthly issue, because otherwise I'll have 240 lines in the spreadsheet, which would be quite a pain. Okay, so what I'm going to do is do the same calculation without the monthly adjustment in. So this was the original calculation we did in the last lectures, and that's the monthly premium. Okay, but I've redone that, so I've made it an annually and end of year calculation. That just keeps it simpler. So because I'm going to project down each year and show you what happens now. So the annual premium on this basis is equal to 200,000 times that over that. Okay, so slightly cheaper because you are paying all your premium up front at the start of the year, and you're having to wait to the end of the year to receive your benefit, so it makes the thing slightly cheaper. But mainly for our purposes here, it actually makes it easier to do the calculation and show you what's actually happening. Okay, so we've got t for time, 0 equals that plus 1. And we'll just go down that 20 years. Okay. So probability, so we now have TPX, that is the probability that this person is still alive at this point in time, which is going to be Lx plus T over Lx, so equals Lx plus T over Lx, so I need to dollar the second one, and that's my probability we are still alive at that point in time. The probability that death takes place in that year is then obviously 1 minus the probability we survive. So we have to be a bit careful, are we doing death in the next year or death in this current year? So let's say at T0 we're looking at the probability of death in the next year. Okay, well the probability of death in the next year is equal to 1 minus the probability of survival, which is that over that, and then we don't dollar it because we want it to be each year, year on year. So the probability of death is about 1 in 1,000 when you're age 35, and it goes up to about 1 in 200 when you reach age 55. Okay, so that is 1Q X plus T effectively. Okay, so what premium are we getting? The premium that's coming in is equal to the annual premium, which we can dollar, okay, times by the probability we're still alive at that point, okay, times by the discount, which is 1 over 1.04, in other words V, to the power of how many years in the future it is. Okay, so that's the present value of the premium. Okay, I should make that present value. And then the present value of the benefit is equal to, well, we've got to be careful with the annual adjustment. So the probability of death in the first year is equal to that, okay, times by 200,000, then times by 1 over 1.04, times by 1 over 1.04 to the power of, it's going to be that plus 1. That is the probability, that's the present value of the benefit, but I've ignored there the probability of surviving to the start of the year, which is also a key part, so I need to multiply that by the probability of surviving to the start of the year. Okay, so the present value of the benefit is 197 in the first year, which is basically the probability of dying in the first year, which is that multiplied by the 200,000 multiplied by 1 over 1.04, because you would get that benefit at the end of the year. So that benefit, the value of that benefit goes up. Okay, you can see the probability of dying is about 5 times as much by the end, but the benefit isn't 5 times as much. But that's because you've only got a certain chance of surviving that long, and also you're discounting because of the interest rate. Okay, so the total value of the premiums is 5,774. The total value of the benefits is 6,006. Right. Right, we have to be very careful here. So let's just do the sum. There is a deliberate mistake in here. When I add up the present value of all the premiums and add up the present value of all the benefits, you'll see they don't add up to the same amount. Okay, but there's 2 mistakes I've made. They're both the same sort of mistake. One is that the benefits are the premiums are payable at the start of each year, so you're not going to receive this last premium. And also, this calculation here is the probability you die in the first year between t equals 0 and t equals 1, and it's payable at t equals 1. Well, the probability that you die between t equals 20 and 21, which is that, is irrelevant. So that comes out as well. So what we get at the end is the total present value of the premiums is equal to the total present value of the benefits. Okay? So, but what you can see is the premiums start high and go down, the benefits start low and go high. Okay? Which means you can't just roll this policy. You're building up a profit here. Well, so profit's completely the wrong word there. You're building up a reserve here, Okay, you should be getting more money in than you're paying out, but you need that more money in than you're paying out, because by the time you get to this point, okay, you're paying out more than is coming in. Okay, because the value of the premiums is going down because of discounting, and the value of the benefits is going up because of the increased mortality. Okay, so this brings us on to the whole concept of reserves, of which there are two types: prospective and retrospective, and asset share as well, which is the practical aspect of reserves, of where you're actually at given the number of people who've actually died. So it's a key issue to realize that if you receive more money in a life insurance company in a year than you pay out, that does not mean you've made a profit. Okay, it might mean you've made a profit, but often it means you've got to store that money to pay out more benefits later on. That's a really key issue. So I definitely recommend doing this calculation yourself. It doesn't really matter what life insurance table you use. I think this table is actually the whole of UK 2018 to 2020 table, which is sort of readily available on the Office of National Statistics website. So feel free to use that one or use any other, but you should always get these two numbers the same if you've got the calculation right. Okay, so that's a good check to see you actually do know what you're doing, and you will see the premiums going down and you will see the benefits going up in this simple sort of life insurance case. Different policy types will have different structures, obviously, of how that's going to take place. But fundamentally, if you've done a pure premium calculation and you just calculate through with all the expected values, all the present values, they should add up to the same thing, because that's what the calculation actually was. Okay, so that's by way of introduction to the fact that there are these concepts of reserves. And then how do we calculate what the reserve is at any point in time? Well, it's a simple present value calculation. At any point in time, if you think right at t equals 0, the total amount of premiums you're going to get in should be equal to the total amount of benefits you're going to pay out. Okay, in the first year you receive £400 at the start of the year, and you'll pay out on average £197, okay, value. Okay, so at the end of that year you should have effectively, you've got to adjust for the time value of money, you should effectively have 401 minus 197, so about £204 in reserve, because over time that's going to get used up. So how do we actually calculate what these reserves need to be? Well, all we need to do is say, well, how much are we going to have to pay out in the future, and take off how much we're going to receive in. If I've got no benefits coming, if I've got no premiums coming in, and I've got a benefit of £100 to pay out, then I need £100. Okay, if I've got a benefit of £100 to pay out, but I've got premiums of £30 coming in, I need £70. Okay, so we just jazz that up a bit with present values and the rest of it, and that is how we do the reserve calculations. So let's do it with the example we have here. So let's calculate, and I'll go back to, because I don't need to actually step it through in the spreadsheet, so I'll go back to the actual premium we used. That was the annual premium, but payable monthly, £417. Okay, so let's calculate the prospective reserve. Don't need a pen that thick. Calculate prospective reserve at t equals 7. Okay, now the convention here is, if you're taking the timeline, okay, 1, 2, 3, 4, you get the premium in at the start of the year, and you get the benefit payable out just at the end of the year. Okay, next premium, next benefit, next premium, next benefit. I mean, mathematically we're saying the premium and the benefit happens at t equals 1 or at t equals 2, but we assume at this point, okay, the benefit of at the end of the previous year has been paid out. The premium at the start of the next year has not yet been received. Okay, it just makes, I mean, in practice you'd have to look at what cash flows have actually come in and gone out, but we use that convention to make the whole thing simpler to analyze. Okay, so we know that our annual premium is 417.265. So what are our prospective reserves? It's very, very simple. It's the present value of the benefits minus the present value of the premiums. That's it. Okay. So what is the present value of the benefits? Well, the benefits are £200,000 times the assurance function we've got. Now we are 7 years. The reserve at t equals 7 is where we're at 7 years in the future. So this 35-year-old is now 42 years old, but there's only 13 years left on the policy. Okay, so it's still a payable immediately on death, but it's now 42. Sorry, not 7. 42, 13. So that is the value of the benefits that are to be paid out. I'm ignoring the expenses again now, and we have to take off the present value of the premiums, which is 417.265 minus the present value of the premiums, which is annuity due, and again it's 42.13. Okay, and that's it. Okay, not sure why I've put a minus there. Just get rid of that. Okay, times. So that's it. That is what our prospective reserve is. Now you might be saying, well, what about the probability they've already died? Okay, that is irrelevant because you are now at time equals 7. Okay, you've gone through all your policy holders, and this person is alive and they have this policy, and this is how much money you need because they have this policy. If they died in the past, there's no longer a probabilistic issue if they died in the first 7 years, because that's now a known fact, because we are now at time 7. Okay, so don't get confused with thinking, oh, we've got to worry about what happened in the past. Okay, we don't. We're just looking forward. We're saying what is the total value of the benefits we're going to pay out, okay, which is this figure. This is the total value of benefits left to pay out. This is the total value of premiums we're going to receive. And we don't have to discount this 200,700 years, because the benefit is £200,000. It will be £200,000. We're now 7 years into the future, so you don't need to put some, v to the 7 in there or something like that. Okay, so that is the prospective reserve. I will do retrospective reserve in the next lecture. If you've got expenses and stuff in there, then that just adds a bit more complexity, but you should be able to see where that is going to go and use sort of common sense for that.